Hello, and welcome to this brief video that will share with you how to use ShieldCore's PortHog technology to easily set up an efficient VoIP network. First, let's begin with the map of our network topology to determine how the VoIP network will be laid out. In this example, we have 8 phones for the chief executives and their assistants, 33 phones for the mid-level managers, and 140 phones for the employees. With the help of the MSA 1806 Managed Service Appliance to program and manage these 48-port PoE switches, we'll prioritize the bandwidth of these phones and virtually eliminate jitter and drop calls, improving connection quality immensely. Alright, so let's take a look at our setup. We've got our MSA 1806 located at the demarcation point with a 25 megabit connection input into EM0. This is a fairly strong connection with a decent amount of bandwidth to play with. Next, we're going to plug several 48-port Power over Ethernet switches in. These are going to power our VoIP phones, and each one of these switches will be plugged into the 8-port switch, which is in turn plugged into EM5 on ShieldCore's MSA. So we'll divide it up like this. The 8 executive phones and 33 manager phones will go on this top switch, while the other 140 phones will divide up amongst the 3 other switches below. These are all going to be put under VLAN 20. Moving forward, when deploying your ShieldCore solution, there's a number of tasks that can be easily performed using our PortHog graphical user interface. So let's start by logging in. Simply type the gateway IP into your address bar, which will take you to the login screen for the PortHog GUI. We'll log in and get to the dashboard. Now, before we do any traffic shaping, let's make sure we're connected directly to the internet to establish our upload and download speeds and to get a solid benchmark. Now, traffic shaping on the outgoing connections is what ShieldCore technology primarily supports. This is due to the unmanageability of incoming traffic shaping. So first, let's examine our various interfaces. VLAN 2 is our local network that our computer is connected to. VLAN 20 is for voice over IP, and the 181 phones will be connecting. And VLAN 3 is our DMZ. Moving up to EM5, this is connected to the uplink on a switch, and EM0 is the incoming internet demarcation point. Let's begin by enabling a queue here on EM0, which is hooked up to the internet. You can use priority queuing or class-based queuing, and in this case we'll be using priority queuing. Now for priority queuing, you've got a range from 0 to 7, 0 being the lowest priority and 7 being the highest. And under max available bandwidth, we'll enter in bits per second, 25 megabit, and under priority we'll select priority of 2, and then select enable queue. So what we've created is a default queue. All packets that aren't classified will fall into this priority queue by default. We'll also add a few more queues here and priorities for the classifications of data. So we'll click new queue, we'll set a priority of 6, and we'll enter the queue name as voice. Save the queue. We'll also make a DNS and a web queue as well. So we'll hit new queue again. We'll select a priority of 5 this time, which is slightly lower than the voice queue, and we'll enter this one as the DNS queue. Hit save queue. When we're doing the web queue, we'll give it a bit of a lower priority because it's not as important as DNS or voice. Now, of course, every other packet will go to the default queue, which is the lowest priority. The reason we give the DNS a slightly higher priority than the web queue is because we want DNS requests to be quick and responsive. Now that the queuing is complete here, you can set your queues to any which way you like. Voice is priority 6, DNS is priority 5, web priority is set to 3, and the default priority is 2. So now what we have to do is classify the data so it can go into the queues or traffic flows. So let's go into VLAN 20's network and see what we can do. Under Rules, we can select Add Rule, and this will allow us to tag the data coming in as voice traffic. So we'll enter Tag Voice Traffic, and for action we'll select Match, Directions Incoming, and the address family is for IPv4 traffic. The source address can be any or can be left blank. And we'll just do this for every IP on the network. You can enter the IP address of the VoIP server if you like. But in this case scenario, let's just classify any traffic coming in from VLAN 20 as voice traffic. We'll use the switches to manage that as voice VLAN. So we enter in the tag that we want to assign it as, and we'll enter _voice. And that will assign the tag voice on any data coming in from that port. It'll all be tagged as voice traffic. We'll hit Save Rule. And there you can see the rule for tagging voice traffic from any source, any destination. So we'll add another rule. This one will be for tagging web traffic. Again, we'll select Match for incoming traffic. We'll select IPv4 again. And under protocol this time we'll select TCP. Now some of our SIP phones on the internet, they connect to port 80 to download configuration. So of course we're going to give that a lower queue, and we'll tag everything going to port 80 from VLAN 20 to the web queue or www queue. And under tag name, we'll put _www and then select Save Rule. So when you classify web traffic, the way you do it is by tagging it. We can tag it by IP address, we can tag it by port, we can tag it by TOS policy, and all kinds of options. So now you've got a tag for web traffic and a tag for voice traffic entered on VLAN 20. We'll go to the firewall rule sets. This time we can click on VLAN 2 and check out the rule sets for VLAN 2, which is our local network. And under VLAN 2, we'll create a new rule to tag web traffic. Again, we'll match, and for incoming traffic, we'll do IPv4. Protocol we'll enter as TCP. The destination port, of course, 80 again. And then scrolling down to tag, we'll enter _www to tag it as web traffic. Hit Save Rule. It's also important to note that when we make a tag, we need to enter it with the underscore before the name, otherwise you get an error message. So now we'll tag DNS traffic. Again, entering match for the action on incoming traffic. Under the address family, we'll select IPv4 and TCP for the protocol. Scrolling down, we'll go to the destination port again. This time we're going to enter port 53 for DNS. And under the packet manipulation, we'll assign the tag name _DNS and select Save Rule. So now that these rules are created for VLAN 2, let's move on to our firewall rule sets. We can take the tag rules where it classifies the data flows. We'll click on Firewall. This is for outbound traffic on EM0. We'll click on EM0 to look at the firewall rule sets for EM0, and then we'll add a rule. So under this firewall rule for EM0, we'll enter a queue for DNS traffic, matching the outgoing or outbound traffic. Under packet matching, we'll leave the address family unspecified, and we'll enter the tag name as _DNS. And under traffic shaping, with the queue name, we'll select DNS _EM0, and then Save Rule. As you can see, the queue for DNS traffic rule is now under EM0. So now we'll add another rule, and this one will be for a queue for voice traffic. The action will be matching, and the direction will be in and out. The queue name will be voice underscore EM0. And the tag name will be underscore voice. Hit save rule, and we're done. So now we have voice traffic and DNS traffic rules set up, and the last queue will be web traffic. So we'll add one more. Select matching for outbound. Type in a queue for web traffic, and under queue name, www underscore EM0. All the other fields we can leave by default, except the tag name, of course. We'll want to enter underscore www, and then hit save rule. Now, instead of applying data traffic flows to tags only, you can also apply them to address types and TCP/IP. You can even do all the rules on the outbound interface, so you don't necessarily have to use the matching feature that we've described. However, matching does give you a bit more control over what's tagged and what's not, and also makes it easier to maintain over the longer term. So now that we have our rules in place, our traffic queues are set up, and our priority queues are in place, and all our VoIP phones should be working absolutely beautifully. Thank you for taking the time to watch this video, and for more information, let us share with you at www.shieldcore.com. Thank you.